So this idea of sum to infinity, also known as the limiting sum. Now this will only work if the ratio is in between -1 and 1. So the absolute value is less than 1. Reason it works is, well, we know when we're looking at our exponential graph, if our ratio is less than 1, so say for instance a half to the power of n, it's like the backwards exponential, and the limit as n approaches infinity will become 0 because it converges as opposed to diverges, where it goes off and gets bigger and bigger. Well, if that's the case, then we can find this limiting sum, because we now know that r to the power of n is going to approach 0, leaving us with a very simple formula, a on 1 minus r. That is our sum to infinity. So the question is, does this have a limiting sum? That's the sort of thing they like to ask, to see if you know the definition. And we basically have to see if it has a ratio that is less than 1. Now, this one, 4/56, is less than 1. I suppose we should check that 2/7 divided by 4 is also 4/56. So, yep, it has a limiting sum. It would converge down. The classic one, frog in the well. You know that one, the frog in the well? You got the frog that's sitting at the bottom of the well, and the first jump it can go half the well, but each time it jumps it can only do half as much each time because it's running out of energy. And the question is, will the frog get out of the well? Well, let's see if the frog gets out of the well. First term is a half, the ratio is also a half. Put that into our a on 1 minus r and we get 1. So the question is, does the frog get out of the well? No, the answer is no, because the sum is 1. To get out of the well, it would have to be bigger than 1. So this stupid frog, right, when it's right at the edge, it's going, oh man, it just can't, never gets out. Okay, this sort of question, it gives us another way of doing it. Write 0.36 repeated as a fraction. Now, of course, if they were to ask me this question, I would just write the answer down straight away using the idea we saw earlier in the year. But of course they might say write it as a fraction by using a limiting sum or something like that. In that case your hand's forced. So we can rewrite it as a series. I could say, well, that's 0.36 plus 0.0036 plus 0.000036 and so on. Our first term would be 0.36. Our ratio is 0.01. Putting it into the sum to infinity form, and we get the answer we were expecting, 36 on 99, which is of course 4 on 11. There we go. That's a nice quick one for today. 1H, 1I.